You're still in
Well, we
the
are we are in a very strict environmental here. Sometimes the signal gets gets
a little
problematic,
bumpy.
So
Yeah.
and because within the concrete walls, etc. But we are back. So these are things
Yeah,
that
it's the
we
issue of doing it live, but it's worth it. Very,
yeah.
very interesting.
Okay.
But you're talking about the applications of this environment
Polymers.
polymer. Yeah.
Yes. So it can be they are applied in achieving increasing the water efficiency distribution in the plants, in delivering efficiency of fertilizer, used in increasing the growth rate of the plants, increasing in order to increase productivity. So you name it, there are many. And we are used with polymers like inorganic components. Actually, it is not, because you see the application, they enter to the human body. They are used for environmental applications in various fields. So this was the second department that we're speaking about. Did I miss anything?
Oh, I think it's perfect. And we can
Uh,
continue.
Okay.
We
one
have
question only, Dr. Florian. If you can ask
Yes.
Dr.
What
Ivo
was the
Kulinkin.
question?
Yeah, are there any kind of polymers that are used for like food purposes? I mean, can you eat polymers? This is the question.
The question is from Mario in Rio de Janeiro is, are there polymers that can be a component of the food for humans, or it does not exist?
Oh, what the food consists of is, of course, water,
Yeah.
polymers.
So water is a polymer, you mean?
No, no, no.
It's not a polymer.
And proteins.
Proteins, okay. Proteins are polymers.
The only component which is not polymer might be fat.
So the only components in the human body that is not polymer is the fat.
Fat, and of course, some,
Is the what?
some
It's
molecules.
the fat.
But
Oh,
basically,
interesting.
proteins is the main constituent part of our bodies, or even the food, of course, are polymers, either from plants or animals.
They're all
They're
polymers. So can we produce a polymer that we can eat? That's the question.
The artificial polymers.
Of course.
So, but he's saying artificial polymers. Artificial polymers, no.
It's not the case.
Not until now. We cannot produce a polymer artificially that we can eat.
But some, I think I remember some tissue engineers developed an artificial beef steak.
So they started to produce artificial beef.
I think they used also some scaffolds at the beginning.
Okay.
For polymers, but then of course it's the tissue, the cells which
Okay.
do the miracle of growth, of course.
So there's a cells who takes over.
And I think any kind of life will survive, even long after humanity.
Does it respond to your question, Mario?
Yes, it does. It does. Thank you very
Okay,
much.
good. Good. He thanks you. So this is microbiological laboratory.
Yes, it is. So this is an important issue with polymers. How they interact with
Could you get the microphone closer, please?
bacteria or fungi. So this is another task which is very important. Mostly, you don't want your polymer items, which are alien things, I find them clothes or somewhere, to be colonized by bacteria. And
Dr. Florian, could you move the microphone closer?
so
Yes.
this is a very common question, which is here studied or tested. Developed materials, new additives, because we need to find a new way how to do it. There are many problems with polymers in this old-fashioned.
Which are the problems?
Of course,
And if you can speak a little bit louder, it's better.
Okay, this
Increase a little bit.
micro particles
Okay.
in the seawater
Better.
and so on, so on. So we are trying to develop the polymers not only for certain functionality, but from the whole perspective of the whole life cycle of the polymer. So also, it's a very important question, not only what happens now with the polymer when I use it, but what will happen after that.
And
We shall recycle it
So it's a recycling.
Deal it in another reasonable way
Mhm.
to keep our environment sustainable.
So the recyclability of polymer, which is one of the issues of the research, correct?
Yes.
It's not only producing new polymers with new properties and application in human body and environmental, but also how to recycle after they are used.
Yes, the whole life cycle of any product must be taken into account.
Recyclability.
Yeah,
This is
That's a
our
basic-
materials.
Dr.
And
Florian,
microbiology, yes.
it's
a
basic
question about
principle.
this. Well, plastic
Making
is a
everything
polymer, and it takes hundreds of years to
short
decompose. Yes.
cycles of everything cycling.
Yes, he has a question, very interesting question.
Huh?
Polymer
Yeah.
is a
Plastic is a polymer, and it takes
Plastic
hundreds
is a
of years to
polymer.
decompose. Is there
It
anything
takes
that can be
years to
done to
decompose.
yeah? Is there anything that can be done to I mean speed up the process? So because we have lots of plastic bottles all over the ocean and things like this, is there anything that can be done to in order to develop I don't know, a polymer that eats the plastic that is in nature, for example?
Exactly. So plastic bottles, all sorts of plastics, some of them are very difficult to recycle. The question is a way to speed up the process of recycling, of decomposing.
Yeah, it must start from the design of the material at the very beginning.
That's true. That is literal recyclability.
Yeah, you prepare
Actually,
such ways.
we have developed years ago the modified paradigm of material science and engineering. In this paradigm of linear, we added the recyclability dimension of sustainability in this paradigm. It's an article, I can send it to you. But it's good. We have to forecast from the beginning when we create a new polymer. What about right now that we have not forecasted? Most of the bottles, plastics around are not forecasted to have a criteria of recyclability because they are produced mostly before we had this new concept. Right now, can be done anything?
What I think is that in quite a close future, these deposits of waste materials will become a source of materials.
Yeah.
I think this all this giant
plastic bottles and plastics
will be served as new raw material.
And correct, but why is this so difficult? Some of them are very difficult to recycle. Why you are saying, okay, let's ban the plastic bags because they cannot be recycled? Well, yeah, that I find is very strange because they can be recycled. Everything can be recycled. What's the problem?
They were developed by humans.
Sure.
Within maybe 100 years or something
Yes.
like that. And the nature developed the polymers, protein.
Correct.
And,
But why you are not able to recycle all the plastics?
Sorry?
Because plastics are polymer. Why you are not able right now to recycle
Yeah,
all the
especially
plastics?
like PET bottles.
Can be recycled by principle. But the other question is organizing it, managing it, and money.
Okay.
The socio-economic factors, they play a role as well.
Exactly.
Even if you have a bright idea.
So they can recycle, but now are not economically feasible and are not at the moment.
We have to do it.
Okay.
And of course, we have to judge.
Well, the sustainability criteria, Mario, sustainability criteria. Basically, we can recycle everything, but to be sustainable, it has to be economically feasible, and it also to be,
Generate social development.
Exactly.
Have a certain meaning because if you are recycled, technology will be more demanding than just landfilling. Okay, maybe you can landfill it.
But then landfilling is still an option. If the new recycling is too costly and takes long time, sometimes landfilling, which is not a desired outcome, but for the moment, if in terms of the conditions of sustainability, sometimes it could be landfilling. It might be the best option, but we don't want that. Right?
Of course, but if it's not avoidable, but landfills of today or the past, there will be mines of tomorrow.
That's correct. But we have to have a new technology.
Could you quote that again, Dr. Florian? I didn't hear. Landfills of today are what?
So, if we have the three criteria of sustainability, it has to be we have to recycle, but we have to recycle in a sustainable way in order to have the to be economically feasible and to be a short time, and then to have value out of it. Right now, although theoretically we can recycle everything, but it's not economically feasible, takes time, etc., etc. This is the issue. So you are not able, you don't have a sustainable technology to recycle. So at the moment, so if you are not economically feasible, if you spend much more time on recycling than landfilling, and the technology of recycling takes time, etc., etc., sometimes it's better to landfill. Sure, this is not a good way of doing things, but if it is the only way, then you have to landfill, and then comes the idea, okay, let's use less plastic. But this is a short-sighted view, because the real focus should be in the new technologies that are feasible, economically feasible, and you can recycle it in a very short time. So here
again,
should be the focus.
Again, what
we agree on that.
We're
on the same page.
Science finds solutions for problems that might, at the moment, not have any solution at all.
Exactly. So far,
and that's why SIPS is so important. Are we going to hear about this at SIPS?
Exactly. That's what we do at SIPS. Science finds a solution for things that today seems impossible, and as is always a solution, but has to be sustainable, economically feasible, to produce value, and to improve human life, and to protect the environment. So they are the three criteria of sustainability. And who can achieve that? Only science and technology. That's why we are here. So he's saying that the plastic, the old deposits today are mines of tomorrow, but we have to have the technology. If we don't have the technology, there still will be the landfilling. So still landfilling is landfill today, but it can be the mines of the new raw materials to recycle these plastics that we cannot do today feasibly. We can do it theoretically in the lab. We can do it.
So
we can build a plant to recycle that, but it's not economically feasible.
So what you have to do today is really separate and create like deposits, like storage for raw material
in order to use it for tomorrow. So that's why sometimes landfilling, if you don't have the raw, exactly, if you don't have the right technology which fulfills the three criteria, it's economically feasible, produce value, it protects the environment, and at the same time is in service of society, then sometimes it's better to landfill and keep it for tomorrow when the new technology will be feasible. Although we don't want that, but this is the right time. But this is all comes to the sustainability criteria, as we discussed. That's why you are here. So,
but sorry to interrupt. Go continue.
Just do this so-called energy recycling, but I don't think it's a recycling in the true meaning of the word. Yeah, because you just burn it, so you get some energy, but you expose carbon dioxide to the atmosphere, and you lose the value of the material, which was actually at the beginning.
Yeah. So sometimes burning the plastics is not a good solution, because you create CO2 and then you use the value of materials from the beginning. You basically lose the plastic. You created something and then you burn it, you create CO2, and then you use the value because you cannot recycle. So burning is not recyclable. I mean, it's not a recyclable strategy. So it has to be avoided. We come to science and new technologies. So now he's specialist in nanomaterials.
Okay, so
your department is nanomaterials. Okay, let's continue.
Very good, interesting visit today, Dr. Florian.
Yeah, this is very good. We know what to choose, you know. So we are entering door after doors here.
Yeah. Well, you're passing through a biological hazard area. I saw that.
That's okay. That is normal. I'm explaining for the viewers. Okay.
So we can use
amazing, by the way.
And still, we are on the shortcuts. Huh? We're not going.
Stairs and so on, but go back and forth and back and forth.
Yeah, that's okay. That's okay for us.
Just to have the shortest walk.
Yeah.
Dr. Florian, tell us a little bit while you're walking about the university itself, because this is a
Yeah.
center, it's a faculty of an institute that is part of a university, right?
Yes, this is the institute, not a faculty, but it's an institute,
Uh-huh.
Polymer Institute.
Uh-huh.
And this is Tomas Bata University in Zlín. Tomas Bata is what is interesting of the university, we can say, is that has the name of a businessman. And no,
Uh-huh.
it's a very rare case in the world. Normally, university has the name of a scientist or a known person, but this keeps is the name of the most famous businessman producing the shoes in the area. So the university comes keeps the name of a business person. This is a very rare
Was he
situation in
who
the world.
created the university?
Indeed, it's a good name for an entrepreneurial university.
No, he didn't create the university. This is an entrepreneurship in university. That's why they gave the
Ah, I
European
see.
University his name. He didn't create the university. No, correct?
Yes, but still we keep some relationship with the family.
So they have still keep the relation with the family.
And
So
some common
Very
research
interesting.
project because the company still exists globally, of course.
a company still exists globally, and the university has the name of the Thomas Bata, the most famous businessman
We were
in the region.
talking before we went live that it has 9,000 students.
Chemical lab. So
Correct. 9,000 students, accredited university, one of the, above the average university in Czech Republic. So, but the most important thing is keeping the name of the businessman. And this is the bridging the gap between theory and the business and entrepreneurship spirit, correct?
And that's what SIPS does a lot, right?
Okay.
we
So again, that's SIPS. Exactly. That's what we do in SIPS. We bridge the gap from, we start from the academia to university and to the industry, to the business, to entrepreneurs. Everybody's in SIPS. So this is kind of, that we are in the same area, in same ideas.
we're
So
Very
bridging the
good,
gap
very
between
good.
entrepreneurship, business, theory, practice, application, all together.
we really combine both basic and applied research all together since we didn't build up an elephant bone tower.
Correct.
Instance,
Yeah.
now we are responsible to the society.
Yeah.
And as you mentioned, in the case of environmental, if the science
Microphone
some
closer,
mess.
please.
so we must clean it.
He's saying if you can speak a little bit louder, it's good for the.
Okay.
Just increase that.
Try.
Try. Yeah. Okay.
Okay. So that.
So you're mentioning if it is good. Can you repeat?
Sorry. Which part?
The last one, the last part. You're saying.
So yeah, if the science did some mess,
Yes.
we have to clean it. It's our duty. Always clean after yourself.
Exactly. So science creates the mess. Science finds the solution.
Very good. Very good.
So this was the laboratory. This is laboratory of chromatography.
So that's
It's used for
analysis
Of-
of compounds.
Yeah.
Basically.
yeah.
And the chemical
Of
analysis.
polymers, still polymers.
Of course, of
Yeah.
polymers. But the polymer is the macromolecule,
Correct.
which is inside the plastic.
Yeah.
But the plastic is actually a complex
Mhm.
compound. It
Mhm.
contains also some molecular components,
Mhm.
some additives, either to protect them against solar radiation or UV,
Mhm.
or to stabilize it and prolong, or sometimes also promote the degradation if you plan the life cycle and so on.
Correct.
So the plastic
Yeah.
is not a simple piece of material, but it's very complex.
It's a complex one. Yeah. So the volume is okay, Mario?
Yeah,
You hear it?
it's good enough, let's say.
It's good enough. Okay. So to return to the point, saying science makes the mess, but science cleans the mess and finds the solution. Well, what is missing here? Because science needs to follow sustainability criteria. If you follow sustainability criteria, you do not create the mess if you restart from that point.
Yeah.
Okay. So since the sustainability criteria has not been there all the time, so sometimes science creates a mess because it doesn't keep the recyclability in the circle. So you have to create it after. So if you started from the sustainability, you don't create a mess, and you don't need to clean it. Correct?
Yeah, that's the new concept.
That's the new concept. Oh, well, this is, by the way, this is an article that we have published about 7 years ago. We call it the modified paradigm of material science and engineering. So the classical paradigm was the linear one. It was from production, properties, etc., in a linear way. Was missing the recyclability, and we added the recyclability and make the cycle. I'm going to send a copy of the article. It is 7 years ago, 8 years ago.
Okay, so we are all these analytical labs.
These are analytical labs, okay?
Well, sorry, what kind of labs are these?
Every of the
They are analytical labs for various properties.
yeah,
Okay.
composition, elemental composition, analysis of gases,
Microphone closer.
liquids, molecules or ions or
You can increase, please. A little bit
okay.
louder.
So for chemical analysis,
Okay, chemical
the
analysis.
composition
Okay,
of any sample.
any sample. Okay, okay. So any properties, chemistry, physics, physical properties, correct? Or physics
is one floor.
is one floor below. So here only chemical properties. This is the floor of chemical properties.
For synthesis labs.
This is the
Synthetic lab.
synthetic lab.
For synthesis.
Okay.
You can see one, so you already seen many
Okay,
because they look very the same.
correct.
Plot.
Correct.
Sometimes one window, two window, but
Mhm.
it depends on very
Yeah,
similar.
yeah.
So
This is an
then
amazing,
we'll
an
go-
amazing visit. Amazing visit.
Yeah.
one of our labs on nanomaterials.
By the way, he's saying this is an amazing visit. For him, it's very interesting.
Ah, fantastic.
So he has only a small
Hope you
complaint.
enjoy it.
He has only a small complaint. Speak a little louder because to make to be.
Yeah, but not only him speaking louder, if you can get the microphone closer. Maybe if
Yes,
you
I
can hold
have.
the microphone would
I'm
be
trying.
better.
I'm trying.
If he can hold the microphone would be better probably.
Correct. Well, can you keep this microphone with you? Just keep it. Like
Okay, so I'll try to keep it.
Yeah, good.
Because
Much better,
You are not
much
the only
better.
one who complains about my voice loudness.
Yeah,
Actually, students at the lectures to solve.
they complain also.
I use microphone. So now I have it.
Okay, good. Okay, we're okay.
I'm happy again.
Okay,
That's it.
yeah,
So here we are in a for nanomaterials.
yeah.
And then we have
So this is your lab.
yeah of our group.
Yeah, okay.
Maybe my, but
Well, I mean your specialty.
the group I take care about.
Yeah. So he is responsible for the research on nanomaterials and advanced technologies. Correct?
Yes, perfect. And
Yeah.
so
Dr. Florian, for the
Just
for
about,
somebody
yeah.
who is Lee, I mean who's not a scientist, what is the definition of nanomaterial? How small does a material have to be nanomaterial?
Okay. He has a very good point because broadcasting is for normal people. So if we have a definition of nanomaterials, very short, not too long.
okay, so the definition of nanomaterials,
Yeah.
according to the European Union as well,
Mhm.
and general consent among the scientists, is that it contains significant particle size below 100 nanometers.
So below 100 nanometers, that's the dimension. Below that,
Okay.
it's considered nanomaterial. It's just a definition,
It's an
Okay,
arbitrary
okay.
arbitrary definition.
You know,
Correct.
if we count in dozens,
Okay.
it will be probably less than 144.
144. If we
Count in dozens.
count in thousands. Okay.
Yeah,
Okay.
but we have 10 fingers, so we have 100.
Oh, okay.
Means the border is depends on because some nano effects emerges at the size of 1, 2, 3 nanometers,
Mhm.
but for some effects the scale length of several hundreds of nanometers may be important.
Mhm.
This is very different, but somewhere must be the border set.
Correct.
At
Correct.
100.
So 100 nanometer below is called nanomaterials. It's
I
just an
see.
arbitrary definition. So that's the purpose of research, working on that level. Correct?
Okay,
Yeah,
very
and as
good.
you can see, here is the lab looks slightly
Yeah.
different than the purely chemical ones.
Okay.
So you see it's mixed between chemistry and physics and
So it's chemistry and physics together.
together. So and we will develop some sometimes we need to work without moisture and oxygen. Then we go to these grow boxes. It's not the only one in the building, of course. So here is used for just some simple preparations, mainly of thin films. Our specialization are thin layers from oxides and polymers that can be used as electrodes in photocatalytic or photoelectrochemical systems. So we started from
photoelectrical chemical system, many application in photography.
I mean, the application is how to use solar radiation or visible light, which is available, but not into photovoltaics to generate just electricity, but to use it without direct conversion to electricity. So we directly use it for some chemical changes.
Correct.
As the plants do. You know, chlorophyll, photosynthesis.
So a kind of simulation of the plants.
Actually, not only simulation, but we would like
to improve it.
Better,
improve it. Okay, good. Excellent. It might be dangerous because you can get out of the hand, or while you can still control it.
I don't know.
Quick question: This black tubes, you stick your hands in there?
It's like a broader.
Just a moment.
So we started from simpler applications, just photocatalytic systems like self-cleaning paints for facades, pigments, which at the same time reflect the infrared radiation or this part of the solar spectrum to avoid overheating of the buildings. Such a project.
Mario is asking. The hands here, you put the hands there. How you use this particular one?
It's a glow box, so you go.
So basically, Mario, you put the hands like this. It's a glow box.
Correct? Okay.
And you go inside like this. I'm doing it here. So that's what I'm doing here.
Okay, it's like a glove.
That's basically in order not to contaminate things. So it's a kind of it's a glove. So
there's biological material in there. That's it.
It's sometimes difficult.
No, I don't think it's biological materials inside.
No.
It is, but you have to have a vacuum. You have to have a clean atmosphere.
Okay.
No moisture.
No moisture, and no oxygen. So you are obliged to keep the gloves.
Okay.
So this is is very important.
Gloves have certain sizes.
So this is my size, I guess.
Maybe your is too big.
So, but anyway, so I tried it. So this is what your question, and a very good question, Mario. So you see that my hand is much bigger than this.
Okay.
So we move to the next one.
It was chosen according to the most frequent users.
Most frequent users. So that mine is not, I guess.
Oh, you cannot get a job there.
Yours is bigger.
We are discussing that.
Okay. So let's do a photo here. We have a photo. Okay. So now we go where?
I'm losing the count. This is the fifth one we're visiting, right? Or fourth?
So now, which department we are visiting?
This is the This is chemistry part.
Chemistry
floor. But there are several groups working. Some groups they do little chemistry, so they have maybe one lab. Some groups have many labs.
Yeah.
But we do not play like every single department is a single.
Because the mix physics and chemistry, it's always mixed.
It's efficient.
But my question is, for now we are going which department?
And we are going to this polymer processing.
Polymer processing. Polymer producing new polymers with new properties and developing new processing technologies. New processing technologies, correct? Okay. And then the last part, it will be
Then we will go for
Energy.
rubbers.
Energy. Oh, rubbers and energy. Rubbers and energies are two remaining. So this is a nice view of university,
Yeah, it is beautiful.
other department of universities from outside.
You're near the
Oh, this
the
is high
border
school.
with Austria,
Sorry.
right?
Sorry?
You're near the border of Czech Republic and Austria.
Oh, it is kind of in between, just about. Is Zlín is in the border of Czech with Slovakia and Vienna. It's kind of close to both of them.
I see.
And if you drive from Vienna, you have the option to take highway through Bratislava or through Vienna. So I took
see.
it through Vienna. So they are kind of in triangle, you know. Sorry, again, you were saying? Oh, that's okay. So that's a high school, not part of university. This is the institute.
Ask him
So
to have the
now we are-
microphone closer to his mouth because I can't hear
Yes.
him.
Yeah, you can keep it a little
You
bit.
will see the reason why we're doing so many floors.
So how many floors are going down?
See?
5, 3, 4,
And the whole building, 6.
6. 6 floors.
Okay, now we are entering the technology lab.
That's a technology lab. New production of new polymers and developing new technology to process them.
Yes, definitely. So that's here now we were in labs where we deal with tiny things.
We are in a micro scale. Now we are in the macro scale. Correct?
Industrial.
Yes,
Okay,
industrial
but
scale.
Even in industrial, it's even
This is pilot scale or industrial scale?
just
Pilot scale.
pilot scale.
Pilot scale.
So
Can you ask him to have the microphone closer, Florian? Please?
Microphone closer, please,
You are
and
from
increase the
all
volume.
classical
Like
technologies
your
of
students
polymer
is saying.
processing,
Okay,
are collected in here and
okay,
wherever for work of the group. So
okay.
you see for discontinuous processing, injection
So injection molding. What else?
going in the other labs which are just nearby. There are some compounding lines to make the compounds. Actually, all plastics are made in a similar way. So we take some basic polymers to mix them. We put some additives, which may be powders, particles as fillers, some chemicals, even liquids can be, and you mix it to get the final material. And
Correct.
then the second and also important part is to develop the process how to make some product from such compounds.
Correct. Okay.
Because polymer is not plastics are not simple materials.
Complex material.
Yeah,
This is the third time you're mentioning. I agree with that.
They have some also time history. They have some memory.
They have a memory.
They have a memory because if you take the same polymer and process it in different ways,
Mhm.
you will get the
Different properties.
Different properties, of course.
So it depends how you process them. You get different properties.
Of course, this is much simpler than the life is.
Correct. But still, it's more complicated than a pure materials.
Yeah, exactly.
Correct. In between, that's in between from pure materials and complex life. In between in our polymers, can we say that?
Yeah, somewhere.
Correct. Let's go. Okay.
Very good definition. I could totally understand it.
And,
Serious.
Yeah.
You see that
Yeah.
all the equipment is that because we don't know what will be the next task, what will be the next company which will come to ask to do some research, to develop a material. So therefore, we have
You have many options to
many
be
options for the
as
technologies.
ready as possible.
And once it's a project,
Yeah.
then you're working a bit like in a campaign.
Okay.
Okay, so we have project to solve this question. Okay, use this, that
Yeah.
instrument. Otherwise, they are kept,
So
as you can see.
So you see, Mario, we have a complex, many departments in this institute, starting from tissues of humans to micro scale to nano materials to industrial pilot. Well, it's not the industrial pilot scale. So from micro to nano scale, it's all complex.
Yeah, it's interesting, serious, very, very.
Yeah.
It's amazing.
Yeah.
Okay, we can continue to the rubber department.
So this is now the rubber department. Rubbers, like tires in the cars, are polymers.
I see.
They are like brothers.
They are like brothers. That's a good definition.
Yeah,
Tires and rubbers.
polymers and rubber.
Polymers and rubbers are brothers and sisters.
I
They
see.
are very different in the use and in the properties during processing.
Okay.
Since to process polymer, here it is thermoplastics, yeah, you just melt it and you process it and mix it for it in more stable. But you can't do this with the rubber.
Correct.
So the rubber needs much more power to be processed.
Mhm.
So we will see
Okay.
different types of machines.
Correct. Yeah. Okay.
And a different smell.
Different smell.
Quality which we can't
Smell.
transmit.
Describe it
Do
for us
you-
because we cannot smell
Do
it.
you are you able, Mario, to feel
I
a different
cannot.
smell?
I'm not. Describe to us. Be my nose.
This is field of research for technology. We should be able to smell through Wi-Fi, and we cannot.
Oh,
We can't.
if we
But
find
I'm
a way
telling
of
you,
doing
it
that, we're going
smells
to
different.
become rich.
It's a nice scientific project.
Correct.
Artificial nose. This is more or less available at this stage of technology, but an artificial producer of smells. Then we have just a phone. We can measure. We can.
Yeah. So we should be able to smell.
The smell, but we can't simulate it.
Yeah. Exactly.
Yeah, if you can imagine that probably 20 years ago we wouldn't be able to do this broadcast.
No,
Maybe
20 years
one day
ago we
we're going to use
couldn't do
smell.
this live broadcasting.
Yeah.
So this,
Here's some-
yeah, exactly. That's where we are. That's SIPS what it is.
These are
Technology.
samples of
Sample of rubbers.
each difference in some.
Wow.
some
I mean, these are real rubbers, biological?
These are real rubbers with different composition, Mario. Different, this is written. Correct? Different composition, different properties.
Then some samples like this one. This for studies from tires.
This is a sample study, different properties for tire.
Like a little one.
Yeah.
Very little one.
Yeah, exactly.
That's the thick.
Mhm.
The experiment on small.
Yeah, so it's all
Then
sample. Correct.
extend the information to the real system.
No.
Ask him to speak closer to the
Don't breathe
microphone.
on.
It's getting a little bumpy, Dr. Florian. The
Noise
connection.
and sound. That is
Sorry again.
noises.
Just a moment. Wait.
No, it's bumpy.
It's bumpy.
The
We don't
connection is
have
a
enough
little
signal
bumpy. I
because
cannot
of
hear
the-
you well.
Yeah, okay. So
Maybe we can
this is the machine. That's a machine for yeah, because we are in better or no?
Well, it's a
Mario?
little bumpy. It's like
Okay.
picture by picture.
Yeah, picture by picture, because we
understand it.
are
It's
in the
better to see
underground.
this than not to see this.
Yeah, it's okay. Okay. So there's a machine about in order to keep the signal because
compounding.
rubber compounding.
They prepare about 1.5 of the compound and see how big is the machine, the motor.
Yeah. Mm. Correct. Yeah. So we cannot photo here. Here. Okay. Okay. No, signal is still there, but it's picture by picture. It's not a good quality.
That's good.
Not smooth. Exactly. Yeah.
Very, very interesting. Very
Okay.
interesting. When you get out of there, I would like you to explain what this is because we cannot hear well in there.
Okay, just keep it closer and a little bit louder, please.
Okay, some other labs, which is, let's say, cleaner than aqua.
Okay, so you just show because of signal. So these are different rubber machines, correct?
Yes.
You're there, Mario?
Yes, yes, we can hear. Loud and clear now.
Yeah, okay.
So that's it. Well, the extrusion in this thermoplastic was simple, like sheet for
Okay.
this can't be done with that. So therefore, the calendering is still a technique, and it's quite a relatively small amount of the compound because it's energetically demanding.
Demanding. Okay. So the specific energy consumption is high.
Yeah. But the source may be natural.
The source may be
Natural
natural
rubber.
or natural rubber. But this is natural or this artificial. So what's the difference between natural and artificial?
The artificial is from some fractions of crude oil, from
Okay.
hydrocarbons obtained
Correct.
from fossils,
Yeah.
while the natural is obtained from natural rubber from latex to this ficus.
Ficus.
I don't know the exact name. Ficus plastica.
Okay. Okay. So
Yeah,
this
we
is
have a lot of
this
these trees
is
in the Amazon, Dr. Florian. In the
Sorry
Amazon,
again?
in the southeastern Asia area.
you have what do you have? I didn't get it.
Rubber tree.
Rubber tree.
Yeah, rubber tree.
Rubber tree.
Yes,
Correct.
we have a
So
lot
that's
in
the
the Amazon.
definition. That's the definition you're
Nowadays,
saying
most
between.
of the tires, most of the tires, the rubber comes from the southeastern Asia. But
Correct.
Brazil is a great
Southeastern Asia.
producer also. Yeah.
But you have in Amazon that you are not using it.
A
Correct?
lot.
So you are using or you are not using?
No, we are using, but due to regulations, yes, we are not going
Too
to
much
talk about this
regulation.
now.
Okay.
They
Understand.
have like
Okay.
it's almost like
So
handcraft. People like extract
okay.
like
So
they
the
do in Canada with the syrup, with that maple syrup. The
okay, I
same
understand.
process.
I understand.
You bleed the
Understand.
tree. Yes.
I understand exactly. So that's the definition. Rubber trees is natural,
Yes,
and artificial one
it's from fossils.
from fossil fuel. So
Fossil fuel.
basically,
Okay.
some fossil fuels can be used for tires.
I mean,
So
not
it's
the
a
fuel.
good,
The oil has certain fraction.
exactly. One of them can be used for tires. So basically, some fraction of fossil fuels can be used for tires, correct? So we are using fossil fuel for something that we use it every day. Can we replace the tires for a different with a different material?
Now, that's a very difficult question.
Difficult question.
Many researchers work on that, but of course, there are some polyurethanes which are elastic,
Hmm.
but
Not enough good properties.
not good.
Not yet.
The second thing
Not yet. New field of research.
is to transmit the momentum.
To transfer the moment, the momentum.
And so it's impossible with polyurethanes now.
So the idea is that okay,
Rubbing.
and
Actually, the name for rubber comes from rubbing,
rubbing.
not from elasticity.
Okay.
If you think about the name,
Correct. Which means that
it's maybe more important.
rubbing is more important than elasticity,
Or maybe
and this was the property not achieved yet artificially,
yes.
and that's why still the rubbers are used from oil, Mario, because some researches have been done to replace them with other artificial materials, some polymers, but they have not achieved yet the rubbing properties.
But
Interesting.
what
Interesting.
about that even the other polymers will be made from oil?
Again, can you repeat?
I'm worried about that even the other polymers
Okay.
will be made from oil.
So he's saying polymers could still is coming from mainly from oil, from fossil fuels.
Yeah.
So you see, the world is not black and white, you know.
No, it's not. It's not. The same thing that can destroy the world can save the world, right?
Exactly,
And
exactly. And that's why you have to
that's
have a
his major
sustainability
science.
criteria. That's the key. Sustainability criteria and sustainability slogan, sustainability framework that has science as a main pillar.
Yeah,
Correct?
everything is in a balance, and the total amount is limited. So as many hours you sleep, you can be awake, and vice versa. So everywhere there's some compromise. You
Compromise.
can't have it all.
How
You
many
know that
hours
my
you sleep?
grandmother used to say that the same thing that can save your life can kill you. Depends on the dose.
Maybe 8 hours,
Yeah.
maybe 7, maybe 6, depends
He's
on.
saying that his grandmother was used to say the same thing that can kill you.
Can
What was
save
the
you.
expression, Mario? Can save you.
The same thing that can save you can kill you. Depends on the dose.
The same thing that can save you can kill you. Depends
That's
how you use it and
how
how.
you use it.
So so that's what that's the key. So from fossil fuel, we have tires.
Dr. Florian, it froze. The image froze. I think it's a connection issue. Probably you're not experiencing. Well, everybody, we had another connection issue with Dr. Florian, who is currently, as we said, at the Polymer Center of the Tomas Bata University in Zlín, Czech Republic. And we've seen all the 6 departments that were to be seen. It was a very interesting visit. So we would like to thank everybody for the presence, and we'll be back soon. Thank you very much. I'm Martin from Rio de Janeiro, and we'd like to thank everybody for watching.